Good morning, everyone. So, this is Manoj Kumar. So, assistant professor. In today's class, we will be discussing the advanced concepts that is of Python, that is numerical Python. So, that we call it as NumPy. So, what is NumPy? It is a numerical Python. So, today we shall go with some of the concepts under that, and next you go with the next particular thing. So, introduction to Python. So what is NumPy? NumPy. So NumPy is stands for num means numerical, py means Python. So under that you go get into the detail. First is what is NumPy. So what is NumPy? NumPy is a Python C extension library for array oriented computing. So you have come across the word array. So what is the word array? Array is a set of elements of same data type. So in Python, the same array, we are going to call it as list. So what the list will contain? List will contain set of elements. So there you call set of items or elements. So here it is list will consist of elements. Okay, so here NumPy will always is work, numerical Python will always work for array oriented. So whether it is one dimensional array or two dimensional array, that we will be seeing. So what are its use? It is very efficient, in memory, contiguous and homogeneous. So these are the properties of NumPy. So what are the properties? It is efficient because using that you can use one dimensional array or multi-dimensional array, and you can work on that. So in memory, so each and everything you will be stored inside the memory. Contiguous. So as you all know, the list or changeable. So changeable. So that's why we take it as contiguous. As arrays, we call it as list. So NumPy will always work on list only. So everyone remember, work on list and tuples. Then only you will get to this particular concepts. So single element. So as we have told an array, how the array will be? It will be a group of elements which will start from 0, 1, 2, and this will be the index and this all will be the values. So it is suited to many applications. What are the application? Image processing, signal processing, linear algebra, plethora of others. That means plethora means plenty of others. Okay, so NumPy is the foundation of the Python scientific stack. So it is the foundation which is required. So you all come across the word what is a calculator. So simple calculator and scientific calculator. It is similar to that. So here NumPy is the foundation for a scientific calculator. Okay, so come for this. This is the ecosystem. First, initially you will be having NumPy. Okay, so NumPy is the very base. So in order to do plus, minus, division, multiplication, joining of two numbers, everything what is required, number will be required. So you have gone with a calci, right? So calci, first it will consist of basic thing. So basic means plus, minus, star, slash with all digits. So that is the operation of NumPy. Come for SciPy. SciPy, it is used for what purpose? For sine, cos, log, anti-log. That purpose you are going with the SciPy. So come for pandas. What is pandas? So it is used for generating a series of numbers. So suppose array, so array I want 1000 numbers. So rather than giving list 1 to 100 or 1 to 1000, using the pandas, you can generate a series of numbers from 0 to 1000 or a number. So to plot any graph, you require this matplotlib. So these are all the basic things up to here. So leave this, it is the advanced one. So up to here are the basic. First one is NumPy, second first level is NumPy, second level you have SciPy, pandas and matplotlib. Okay, so now you come for the quick sort. So you will be starting with what the numerical Python is, that is NumPy. So NumPy will be abbreviated as NP. So N stands for number and P will stands for Python. So it is used for what? it is used for the an array. So that will be represented as np dot array. So come for here. If here you see first line what you are having, import numpy as np. So that means your numpy is a package, Python package. Okay, so you have to install. So that's why we give it as NumPy as NP. Okay, so when you now after importing, first you put some values into that. So A is a variable. So here you see A is a variable which contains it is a numerical Python variable which consists an array elements of this much. Okay, so suppose I want all these values to be stored in a variable, then you have to go with NumPy concept. Okay, so if you have 100 values also, you can sort it in, you can store it in NumPy using the NumPy concept into a single variable. Okay, so how to store? So for that you take it as A is equal to np dot array. What is np? NumPy. What the NumPy will consist? It works on array. So what the dot array? So dot array with its values. Okay. So now you print. Now you see here. So in means input, out means output. That I will tell you when I go with the example. So now I have stored A is equal to this initialization is done. Now I print the value of A. What is just I am giving it as A. So what the A will consist of? It will consist of an array. So keep in your mind. So array inside you are having list open and list you are getting list close. Understood? So that is the concept here. Next you come for, next you see. So this is one dimensional. So it is one dimensional array. How many you are giving? So it is inside one dimension. How to take two dimensions? So that is you go with a matrix type. So for matrix type you see I will be taking so I have these are the values you are having. Same thing I am using here to represent it in two dimensional. A dot reshape of 3 comma 3. What is A dot reshape? Reshape means change from one dimensional to two dimensional. So a number of elements, how many you have given? 9. So 3 comma 3. Depending on number of elements, you have to give the shape. Okay, so now B is equal to A dot reshape. For what purpose you use reshape? You are going to use it to convert from one dimensional array to two dimensional array. Now you see that it's been stored to where? B. So when I just print of B, what I am getting in the form of an array. So as you have two dimensional, so first dimension will be rows, second dimension will be column. At that time, you will go with the array of 1, 2, 3, 4, 5, 6, 7, 8, 9. Understood? So now you come for the statement B. You are having B star 10 plus 4. Star 10 plus 4 means what is the B value? For that you multiply, you add 14. Okay, so multiply with 10 plus 4. So first, what is the B value? 1. 1 star 10 plus 4. 1 star 10 is 10 plus 4, 14. Similarly, come for next one, 2. 2 star 10, 20 plus 4, 24. This is the array operation. Now you come for the array shape. Okay, so array shape you can have one dimensional or two dimensional. No two dimensional, it is n dimensional, 1D or ND. So that will be the concept here. So 1D means only one array bracket close will be there. N dimensional means you will be having two, one dimension for row, the other dimension for column. Understood? So that is one dimensional array have one type of further shape. Okay, so how you give the one dimensional? All the elements in one row. So that is one dimensional will have one row, whereas two dimensional will have n number of rows with columns. But one dimensional will have one row with many columns. So can you tell how many is the value? So here you have started with 0 to 8. So what is the shape you are going to give? You are giving it as 9 comma. So shape is 9 comma. So two-dimensional arrays. So two-dimensional means, so what have that? Two tuples. So one for row, the other one is column. So here I will be giving it as 3. So what is 3? That will represent rows. So first row, second row, third row, and 5. What is 5? It is the columns. So how many columns? Column 1, column 2, column 3, column 4, column 5. Okay, and so on. Suppose you are having multiple. So see the example here, 3 comma 5 comma 4. That means 3 rows with 5 columns. That type how many? 4. So that's why you see here, this one is how many rows? First row, second row, third row, 3 rows. So each one is having how many columns? 5 columns. And that type how many arrays should be created? 4 arrays are to be created. Understood? So array element types. Which are the array element types? Now you have to see. So element type are nothing but data type. So how many types are there? Integer, float, char, string. Okay. So now you come for the NumPy array comprise elements of single data type. Because what is an array? It is a group of elements of same data type. Okay. So single data type. The object is accessible to dot type variable, that we will see what is dot type. So it will describe the data type of that particular attribute. Here are few of the attributes. One is the byte order, that is for big or little Indian, item size, element size, name and type. So type represents the data type. So now you come for this particular thing. So now in means input, out means output. So here I am taking a is equal to np dot array of 1, 2, 3. Okay. So what is a? It is a numerical Python variable. So which contains how many values? So here you see it is 3 values in one row. Okay, 3 values in one row. So for that time I will be giving it as now you see what you give a dot d type. So what the d type means? Data type of the variable a. So what are the values you are having? 1, 2, 3. So what will be the data type? So data type will be integer, that you give it as int64. Now you come for the next one. B is equal to np dot array of 1 comma 2 comma 3 comma 4 5 6. Okay, so now here 1 2 3 are of integers, whereas 4.567 is of floating point. Integer with float. So what is the data type you will be getting? Higher one will be the output. So higher one which is float, because it takes 4 bytes, whereas this one will go with 3 bytes. Okay, so that's why we take it as float. So suppose you can also specify say explicitly. Okay, so explicitly if you div, you see a is equal to np dot a is equal to np dot array 1 2 3. D type is equal to np dot float 32. When I give a dot d type, what you will get? It is of integer. So what is a? Only give only a, it will show you array of 1 dot 2 dot 3 dot. Accordingly, you are assigning a dot d type means it will go with a integer only. If you assign d type is equal to float 32 also, values, what values you are giving? 1 2 3. So it will take it as integer only. Okay. So NumPy built-in data type hierarchy. So this is the built-in data type hierarchy. So kindly go through. So what you are having, first is Boolean and object, that you keep it different. So next you have number, next you have flex. Okay. So flexible means there you will get character. Under number part you will get integer and indexed. So indexed means float integer means unsigned. So under that, these are the data type hierarchy. So array creation. So how you create an array? So how you create? You give it as np.array. So come here. So np.array of 1 2 3 4. If you like give like this, it is not stored in any variable. Keep in your mind, it is not stored in any variable. At that time, you print array of, when you get this, output will be array of 1 2 3 4 as range of values. Suppose rather than giving 1 2 3 4, if you want to give it in terms of range, so at that time you have to take a range of values. So keep in your mind dot array, you have to give the values inside the list. But when you go for range, so a range of 10 will get you 10 values. So what is the values? 0 to 9. Okay, suppose if you want the one particular value, okay, so what should be done? You see here, by specifying number of elements, you can give a dot linspace. Number of elements will be represented as linspace 0, comma 1, comma 5. Start with 0, end at 5, end at 1 with a interval point. Sorry, how many numbers? 5 elements you should get. Okay, so what is the first one? Starting element is 0, last element is 1, and like this, how many you have to get? 5 elements. So come for here. So here I have taken it as 0 point. Next, this one is 0.25. Next one is zero point 0.5. Next one is 0.75. And next one is 1 dot. So this is how 0 will represent the starting element. 1 will represent the last element. 5 you will be getting any random numbers. Okay, 0 initialized. Suppose if you want a group of elements with 0, so what you have to do? That is zeros, np dot zeros of 2 comma 2. So how many are there here? 2 comma 2. So 2 comma 2 will go for integer. That is two dimensional. So two dimensional means 2 rows, 2 columns are to be provided. So 2 rows, 2 elements. When you print, you will be getting. So put for total how many elements? 2 cross 2. So it will be 2 cross 2 is equal to 4. 4 elements. Okay. All the 4 elements will be initialized with zeros. So 1 initialized. Go with np dot ones of 1 comma 5. So what is 1 comma 5? 2 comma 2 means 2 rows, 2 columns. 1 comma 5 means 1 row, 5 columns. So under 1 row, 5 columns, you put all the elements with 1. So keep in your mind, initialize means giving the values to the array. So zeros initialized, you put all the values 0. If you want all the ones, so np dot 1 uninitialized. So suppose now you see here, so np dot empty of 1 comma 3. That means one row, how many columns should be there? 3 columns. Okay, so when you give empty, some garbage values will come and sit here. Okay, so np dot zeros, np dot ones, np dot empty. So constant diagonal value. Suppose now you see np dot I of 3. np dot I of 3, what you will get? All the diagonal elements will be placed with a value 1. Okay, so I of 3, that is the syntax you have to use. np dot I of 3 means you will be getting three rows where each diagonal element will be placed to 1. So see here, first element, second element, third element. Multiple diagonal values. So my DAC of 1, 2, 3, 4. Okay. So there you have didn't specify anything, but here I am going with a specifying each and everything. So in first row, first element will be 1. Second row, second element will be 2. Third row, third element will be 3. Fourth row, fourth element will be 4. That is multiple diagonal. So array memory layout. Okay, so how the memory is stored? First, this is the header. So first you go with a data type, and then here you go with a value. So indexing and slicing. So very important concept. Indexing and slicing. So indexing means what you will get is you have to see. So what is indexing? So here you see. So I've taken array. So inside array, you have gone with 3 rows and 5 columns. So how many rows you are having? 3 rows. So on inside the 3 rows, so inside 3 rows, there are how many element columns? So you are having 5 columns. So all 5 columns I will be seeing here. So, so now you see indexing means, so you are starting from something and you are ending with something. So you are 0 to 2, 0 colon 2 comma colon. So that will represent all the values. So when you go with the second row, leave the first element. So this one is called as a slicing and this one is called as a indexing, that we will see in the examples. Okay, so now you see here, so out of 2 rows, so out of 2 rows, which are the 2 rows here? So copy, start from second column and third column. 2 column 3 means 0th column, first column, second column and third column out of 2 rows. So 2 rows, second column and third column. So that is the value. So array indices. So now you come for here, can also take an optional straight. So now you have to go with here. So no starting, no ending, nothing is specified, just you go with a 2. So going with a 2 means, so 0, so you have to go with 2 columns. So you left this one, you consider this. You left this one, you consider this. You leave an optional one. So now you array of colon 2, colon 3. So colon 2, colon 2. So what is colon 2? So starting is nothing, ending is nothing. You consider this row, that is this one. So you have to go with how this row. This is 2. Okay. So this one is 2 and this one is 3. This one is 1, this one is 1, this one is 1. This is 3 with, this is the row number, that is 2. Understood? So this you have to consider. Array views. Now you come for each and everything you will get to know now rather than comparing there. So array views. Simple assignment, do not make copies of the array. Slicing operation, do not make copies either. They return values on the original array. So now you see here, so very important. I created an NumPy variable A which takes np dot arrange of 10, np dot a range, array range of 10. Okay, array range of 10 means it will start from 0 and it will end at 9. Okay, so b is equal to a colon 3 to 7. Okay, it will start at where? 0 and it will end at 9. So third, which is the start from third element. So first element 0, second element 1, third element 2. So leave that off the from 3 you start. So third element 3, 4, 5, 6. Okay. Suppose now you see here. Now I will give b colon is equal to 0. What is b? So now when you go with an a, what you will be getting? You will be getting 0, 1, 3. You will be having this much zeros followed with 7, 8, 9. So universal functions, ufuncs. So NumPy, ufuncs are functions that operate element-wise on one or more array, which are the universal functions that you will be seeing here. So take this ufunction for addition. So this is one NumPy array, that is NumPy array, which is of how many rows? 1 comma 5. So 1 comma 5 means 1 row, 5 columns. So similarly, b is equal to np dot array of 1 comma 5. What is 1? 1 row and 5 columns. So c is equal to a plus b. So it is used for the universal. That has many built-in functions. Which are the built-in functions? You can usually know this one: comparison, lesser, greater, arithmetic, all, exponential, x, log, power, square root, trigono, sine, cos, tan, hyperbolic, sin h, cos h, all this, bitwise, logical, predicate, everything. So now you come for the axis. Array method reductions take an optional axis parameter. It's a optional access parameter that specifies over which access to reduce. Access is equal to none reduces into single scalar. Suppose you see here a dot sum. You go with a statement a. So create an array. So what is this array you have taken? It is a two-dimensional. How many rows are there? Three rows. How many columns are there? Five columns. Now you go with a dot sum. So what it will do? It will go with the so axis is equal to none. Suppose if you give axis equal to 0, 1, now what will happen? Now you see axis is equal to 0 reduces into 0th dimension. All elements will be only 1. Okay, so now when you have axis is equal to 1, now you see a dot sum of axis is equal to 0 you have given. Okay, so what will be the a of sum when axis is equal to 0? You have to add this one. So what we can get? So out array, first you will be getting 10 plus 5. Axis is equal to 0. So 10 plus 5, 15. So now you come for this one. So this axis, no axis, I am not considering any axis now. Okay. So now what is the answer? 11 plus 6, 17, 17 plus 1, 18. Next 12 plus 7 plus 2, 19 plus 2, 21. Next 18 plus 8 plus 3. So it will be 24 like this. So this is for, so when you have axis is equal to none, you will be having the value 105. When axis is equal to 1, you will be having like this. When you have axis, now you see when axis is equal to 1, you get the value 10, 35 and 60. So 10, 35 and 60, it reduces it into the first dimension. So now you come for broadcasting. So if you have not understood also, when you work on your practicals, you will be getting that thing. So, so key feature. So coming for the broadcasting. Okay. So key feature of NumPy is broadcasting, where arrays with different but compatible shapes can be used as argument. So now you see. So this is A. So this is A. So C is equal to, rather than going with A plus B, suppose you take it as C is equal to A plus 10. So this is the broadcast method. The slightly more involved broadcast example, C is equal to A plus B. This is A, this is B, C. 0 plus 10. So 0, C is equal to A plus B. So how you take the values? So how you take? So now you see, so this is a small change, 0 plus 10, 10, 1 plus 10, 11, 2 plus 20, 22, 3 plus 20, 23, 4 plus 30, 34, 5 plus 30, 35. So this is the, here an array of shape 3, comma 1 is broadcast to a shape 3, comma 2. 3, comma 1 is being broadcasted into 3 with 1. So here also it is 3 with 3 rows, 2 columns. Here it is 3 with 1 column. So what you are getting? So you are getting 3 with 2 columns only. That is broadcasting. So broadcasting rules. In order for an operation to broadcast, the size of all trailing dimensions for both arrays must be either B equal or B1. Okay, so it should be like this. If A is one dimensional and B is two dimensional, result will be 2. If A is two dimensional and B is three dimensional, result will be 3. So if A is 4 and B is 3, result will be 4. So higher dimensional one will be the result. So next you come for the concept, round hole. Okay, so this is the next concept what you are going to discuss here. Square peg in a round hole. If the dimensions do not match, okay, so if dimensions do not match, so then you have to go with np.new axis may be useful. So dimension how it should be. So I have already told here 1 with 2, 2, 2 with 3, 4 with 3. Okay. Suppose if dimensions so 1 with 3, so 1 with 2 should be there, 2 with 3 should be there, and 3 with 4 should be there. Suppose you go with 1 with 3 or 1 with 4, so broadcasting will not be applicable. At that time, you have to go with, if dimensions do not match, np.new axis. So you have to add a new axis for that. So for take the example, a is equal to np.range of 6, reshape 2 comma 3. Okay, range of 6 means 0, 1, 2, 3, 4, 5. So 5 elements are there, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5. Okay, so you have to reshape it in 2 rows and 3 columns. So 2 rows and 3 columns means 0, 1, 2, 3, 4, 5. Okay, so now B is equal to np dot array of 10 comma 100. So here A is of how many, what much size? 2 rows. Here B is array of 10. So 2 should be there with 3 only. Okay, so 2 with 3, but here you are crossing with 2 with 10. So 2 with 10 will result in error. Okay, so what is the error you will be getting? Operands could not broadcast together with shape 2 comma 3 comma 2. Okay, here it is 2 with 3 and here it is 2. Okay, so 2 should be there with 3. So for that you go with B, np.new axis of shape. So this is the syntax. Output you will get 2 comma 1. B colon np.new axis dot shape. Okay, so now you can perform any operation. So that is broadcasting. So now you, after you get base of size 2 comma 1. So now 2, here also 2, here also 2. So at that time 2 cross 2, result will be in 2 rows. So 2 rows you are getting the result. So now you come for the array methods. So which are the array methods for predicting? If you want to check, you go with any and all. If you want any reduction, you go with functions mean, argmin, argmax, trace, sum, and cumprod. Manipulation, so these are the methods. Complex numbers, real number, imaginary number, conjunction. So fancy indexing. So now you come for some of the other concepts. Okay, so now you have gone with broadcasting. So hereafter you keep that one in your mind. So A is equal to A range of 15. So range starts from 0 to 15 elements you have to get. So 0 to 15 you will be getting. Reshape it in 3 comma 5. That means 3 rows and 5 columns. So what is A? So now you are be printing. So 3 rows and 5 columns. So 3 rows, 0 and 5 columns. So each row will have 5 elements. So 0, 1, 2, 3, 4 is first row. 5, 6, 7, 8, 9 is the second. Next 10 to 14 will be the next. Okay. So now you come for the I is equal to np.array 0, 1, 1, 2. J is equal to np.array 2, 1, 4, 4. So what you will be getting? Can you expect? So 0, 1, 1, 2. And J is equal to 2, 1, 2, 4, 4. So what is A of Ij? So A of Ij will be, what you will be getting? So output will be 2, 6 and 9, 14. This will be the output that we will see in the hands-on session concept. So when you go with the hands-on session, we shall see there. So Boolean arrays can also be used as indices into other arrays. Okay, so how you, for that you have to go with a range and shape into 3 and 5 columns. Okay, so this will be the 5 and columns. Now you see B is equal to A mod 3 double equals 0. So B is equal to A mod 3 double equals 0. That will be the B. So now what will be the B? We shall see 0, 0 mod 3 double equals 0. What is mod? Mod will give you the remainder. So 0 mod 3 double equals 0. Yes, true. 1 mod 3. 1 mod 3 double equals 0. What is 1 mod 3? 1 mod 3 will be 1. 1 double equals 0. Addition false. Next to 2. 2 mod 3. That will be 2. 2 double equals 0. False. Next 3. 3 mod 3. 0. 0 double equals 0. Condition true. So that will be the finally you print a of b. What are the true values? 0, 3, 6, 9, 12. That will be printed here. So NumPy functions. So which all the functions you are having? So mesh creation, manipulation, and data IO. These are some of the functions we are using for NumPy. So array subclass. So MA, masked array, matrix operator, memmap, memory mapped array, record array. So other sub packages are polynomial, math, random. These are some of the advanced concepts. For now, you work on that. Now you come for the examples. So coming for the examples, we will go with this is a Fourier transform. So what is this? We are going with a Fourier transform that we will see when I go with some other concepts. Okay. So for any resources, you can refer this particular site. I hope you understood this particular topic now. So so I hope you understood. So this is the lecture about the NumPy. So next we will go on to the practical sessions on NumPy in tomorrow's class. So now I will be ending here. Any doubts you can contact me. Okay, I hope you work here and understood. Okay, thank you.